Hi everyone. Today we will discuss one of the interesting topics in number theory, which is called Legendre's formula. It is the formula itself here, but let me explain this. Firstly, we have number p, which is prime, and number n, which is a positive integer. And in this case, we just want to find the greatest exponent of p that can divide. Let's call it, for instance, in this case actually vpn factorial, and actually it divides n factorial. For instance, in 10 factorial, 25 can divide it easily because we have 10 and 5. However, 125 cannot divide 10 factorial because we don't have one extra 5 here. Also, I can say like this: we just find the number of p's, prime p's, individually in n factorial. Let's solve an easy question here. For instance, let's say we have 80 and we want to find the number of 7s in 80 factorial. So we just use this formula: floor function of 80 divided by 7 plus floor function of 80 divided by 49 plus floor function of 80 divided by 343, etc. Actually, in this case it is 0, so we don't need to find the other ones. I mean, when the power is greater or equal to 3, I mean the power of 7. But in this case we have 1, and here we have 11. So overall we have 12 sevens inside of 80 factorial, or in other words we can say that the greatest power of 7 is 12 that can fully divide 80 factorial. It means it is possible, but this one, when the power is certain, it's not possible. Okay, actually sometimes people can ask why we divide 49 after 7, because we have already divided it by 7, but it doesn't work like this. For instance, let's say it is first row and there are numbers here, and all of them contains one prime number, I mean divisible by one of the prime number. In this case we have, for instance, 7, so we can write 7, 14, 21, 28, and it goes like this. However, in the second row we have also some numbers, but they are also divisible by p. P square can divide them. We can select this. For instance, we have 49 here. However, we have already written 49 here because it is divisible by 7. So that is why we just add additional 1 here for the power of 7 to show that 49 contains 2 sevens. Let's say we have 905. In this case we have 5 can divide some numbers inside 900 factorial. We have 25 that does the same thing, also 129 and 629. As you can see, 629 can be divisible by 5, 25 and 125 at the same time, as well as itself. So that is why for 25 we just add the fourth row here. Let me do it more properly: 1, 2, 3 and 4. So the numbers that can be divisible by 625 will be written here: also here, also in the second row, and in the fourth row. So that is why we just use the same number 4 times, because it contains 4 5 it's in itself, and it works like this. So that is why in each case we just delete one row, and it means that there are, for instance, let's divide it by 5. Actually, let's do it like this in the for function, and it is 180. In this case, we show that there are exactly 180 numbers that can be divisible, that are divisible by 5. Actually, it also contains 25, 125, and 625 also. In the second row, we delete some numbers that is divisible by 5 but not divisible by 25. So we just exclude these numbers. In this case, we don't have, for instance, 10 here, but we will have 50 here, because 50 is divisible by 25. Also 500 can be here, but not 505. So in simple terms, we just find the powers and the number of powers actually in a specific factorial. Let's go back to the question actually, that I have written above. But firstly, let me just delete here, because we need some empty space to solve the question. Okay, I guess everything is ready. It says how many zeros are in 100 factorial. For zeros, actually it means 10. So basically it says what is the greatest number, power of 10, that can be easily divisible, that can easily divide 100 factorial. Let's say it is a. But there's a problem. We said that we use Legendre's formula for the prime numbers, but 10 is not a prime number. However, we can just divide it two parts, 2 and 5. It is obvious that there are less number of 5. The power of 5 is less than the power of 2. So that is why if I calculate 5 for the number of 5s in the 100 factorial, we will easily find the number of 10s also. It means the number of zeros actually in this according to this question. Let's find it. We have, let's write it properly. We have 5. Also 25 can also fit here, but not from 125, they don't fit. So from now on it is 0. We don't need to calculate this. 100 divided by 5 is 20, and when we divide 25 divided by 25, we get 4. Overall we have 24 5s inside the 100 factorial. It means that the greatest exponent of 5 is 24 when we want to divide 100 factorial by 5, the greatest numbers of 5. So it means that there are 24 zeros in 100 factorial. Thanks for watching, and don't forget, get math, be best.